Hello students, hope you are all doing good. Welcome back to Programming in C language. This is your Sreekanth. In the last session, we had discussed in detail about what is data, what is information, what is the difference between data and information. Okay, so if you are listening this session before, must go through the previous session. If you missed the previous session, first go and check it out the previous session, then only come to this session videos, then only you can understand completely about the today's agenda topics. Okay, yeah, so still we are in the computer fundamentals unit 1 part 1 section. The agenda of this session: data hierarchy, bit representation, examples, related examples. See, in the last session, in the previous videos, we discussed in detail about what is data, relevant examples, what is information, relevant examples about information, how the data is going to be different with the informations. Some points also we discussed, data versus information with suitable examples. Okay, yes, today we try to discuss in detail about what is data hierarchy, what is bit, how to represent the different bit representations. Okay, it helps more in the programming language. I give some clarity related to the bit representations in the today's session. Okay, yeah, see, coming to the data hierarchy. What is data hierarchy? Data hierarchy refers to the systematic organization of data, often in a hierarchical form. Data organization involves characters, fields, records, files, database, and so on. Okay. See, what is data hierarchy? In computer system, this is the hierarchy of the data is going to be represented what? Systematic organization of data. Okay, in a hierarchical form. Data organization involves generally characters, fields, records, files, and database. Okay, what is bit? In the previous session, we got some brief discussion about bit, right? Bit represents, it is a smallest unit. It represented either 0 or 1. It is the smallest unit of data. It represented by what? 0 or 1 in a computer. We sometimes may also call on or off, plus or minus, like that. Okay. Byte. What is byte? The combination of 8 bits. This is a 8-bit combination represents what? 1 byte of memory. In computer, I want to store any character through the help of programming language, especially like C and C++. I want to store any character in a computer memory. It required at least 1 byte of memory. 1 byte represents what? 8 bits combination. Each bit represents what? Either 0 or 1 representation. Here zeros or ones are nothing but what? Binary representation, binary format. Because machine always understands what? Machine understandable language or low level language or machine language also sometimes we may call it. Always it understands what? Zeros and ones representation. Okay, the combination of 8 bits represents what? 1 byte of memory. Using this 1 byte, we can happily store 1 character into the memory, like A, B, C, like that. We may store any one of the character into the memory, either character, symbols, okay, and so on. What is field? Field represents what? Combination of bytes. The collection of these bytes represents what? Field. Here the fields are, we can also call names. Okay, example like student name, employee name, department name, ID, mobile number, date of birth, gender. I want to store some field information into the memory. Then we go with what? Field. Field is nothing but what? Combination of bytes or relevant categories. Record is nothing but what? Combination of fields or collection of fields represents one record. Example, I want to store what? Student information. Then what is the basic information of student? Like student ID, hall ticket number, name, date of birth, email ID, mobile number, and so on. So this is represents one record of the student. Like we may insert any number of records based on what? Fields. Record is nothing but what? Combination of fields or collection of fields represents one suitable record. We may write student record, employee record, department record, and so on. What is file? File represents here combination of records. We may store all these records in one file format. See, different types of file format supported by computer, like text files are there, documents are there, PDF file formats are there, like so on. Different file formats it going to be supported. Okay, here just you can remember it. File is nothing but what? Collection of records represents what? One file. We may store those records into one file, like a student file. It consists all student related record information. Employee file, it consists all employee related information. Department file, it consists all department related information. That represents represented by what? A file. And coming to database, see, this is what? Largest unit of data. Bit is the smallest unit of data. Database is what? Largest unit of data. In database we can able to store huge data. See, in database we may create what? Users, DBAs, okay, tables. We may store there within a table like fields, records, structures, files, indexes, views. Like we may store huge number of data in the form of in a database. Okay, just remember here, database is nothing but largest unit of data. It consists what? All the information, like field information, records information, files information, and so on. If you learn in the advanced level, we have one separate subject like database management system. There we may learn in detail about these databases. Okay, but the basic idea before starting with the programming, what is data hierarchy and what data hierarchy consists. Okay, data hierarchy refers to the systematic organization of data. It's going to be represented in the form of what? Bit, byte, field, record, file, and database. Here bit is the smallest unit of data represented by 0 or 1. Database represents what? Largest unit of data. It's going to be store huge volume of data. Okay, here byte represents what? 8 bits. Combination represents 1 byte. Using this 1 byte in programming, C++ especially, we can able to store one character. Okay, like A, B, C. I want to store one character in a memory, required 1 byte of memory. 1 byte represents what? 8 bits of memory. Field, like collection of bytes represents field. Records, collection of fields represents a record. Field means collection of bytes, record means collection of fields, file means collection of records, database means what? Collection of all these things, fields, records, files represents what? Database. So this is about data hierarchy. I give much more clarity related to this hierarchy. Bit, just only I told, represented by either 0 or 1. Byte represents 8 bits, represents 1 byte of memory between 0 to 255. So in the coming slides I explain clearly, sir, what is this 8 zeros, 8 ones, why it represented by 0 to 255. In the coming next slides only I will discuss in detail about byte. Just remember here, byte means what? 8 bits. Combination is called 1 byte of memory. See why I am talking about here memory? Because we are communicating with the computer, we are passing some instructions to the computer. That instruction is going to be stored into the memory. Okay, their memory is going to be represented, the smallest unit represented by bit. The combination of bits, 8 bits represented by 1 byte. Just remember, the 1 byte is in between combination of 8 zeros, 8 ones. Okay, in the decimal value 0 to 255. Okay, field, just only I told, coming to the student, like ID. Yeah, here ID represents field name or column name or name of the student, like that. ID is a student related field. Name is nothing but what? Field of the student. Course is nothing but what? Field of the student. Like we can write, coming to the employee information system, We may give field names like employee ID, employee name, employee date of joining, employee date of birth, employee salary, so on. Like that we can represent employee related fields. Coming to student, I taken only 3 columns here: ID, name, and course details. Okay, ID, name, course is nothing but fields of student. Okay, and what is record? Record represents what? See, this is about what? Records. I am going to be filling the values of these fields. 101 is the value of ID. SreekanthDeva is the name of the student. Python is the name of the course. Like 102 is the ID of the student. Sai is the name of the student. CPP, the course of the student. 103 is the ID of the student. Bhuvi is the name of the student. Android is the course of the student. So this is 101, 102, 103 represents what? The course. Student records, we can call it 101 record, 102 record, 103 record. So in future if you go with the hall ticket number, based on a hall ticket number we may get the results or not. Yes, see, that is called record or information. Okay, see, a record is nothing but what? This is collection of fields represents what? These record information. Okay, and file, I want to store all these student data in one file. That represents what? Student file. Similarly, I am storing all the employee related data and information. I am storing one file called employee file, like department file, like that, so on. We may create n number of files. Database is nothing but what? It's going to be organizing all these things. Okay, it may consist fields, information, records, files, blobs, binary large objects, glob, character large objects, and so on. It is the database is nothing but what? Largest unit of data. Bit is nothing but what? Smallest unit of data. Okay, so this is a story about what? Data hierarchies. Okay, you need to remember these point: bit, byte, field, record, file, and a database in computer. Okay, fine. See, today I try to give much clarity about what? Bit. What is bit? Bit is a atomic, the smallest unit of storage. It represented by what? 0 or 1 representation. Why I am discussing in detail about bit? Because so many students are failed to understand this topic. Due to that, very difficult to understand in the data types in C language. Okay, their ranges sizes are vary from one data type to another data type. That's what I am giving some little bit understandability about this bit and conversions representations. Here bit is nothing but, just remember, bit is a atomic, the smallest unit of storage. It represented by what? 0 or 1. See, generally, if you go with electronics or some other physics or some subjects, they may represent like on or off, true or false, yes or no, plus or minus. But in computer, remember, it represented by what? Binary format, 0 or 1 format. Okay, we can call it is binary digits. Bi means what? Two digits, 0 or 1 representation. Okay, a group of 8 bits is known as what? 1 byte. I told you these combinations, bit combinations, 8-bit combination represents what? 1 byte of memory. Okay, so this is the representation here. It is represented in between the 8-0 combination and 8-1 combination. The value of 8-1 here, it goes 256, but we are representing here 0. That is the reason 255. How it going to be measured? It going to be measured 2 to the power of x equals to y. Okay, 2 to the power of x equals to y. So now I try to give much clarity about what is this 2 to the power of x equals to y, how we are going to be representing bits. Now we'll discuss in the next slide. Okay, so here in this slide you need to remember about what is bit. Bit represents what? Smallest unit of storage, represented by either 0 or 1. That's fair enough. Okay, up to here clear? Yes. See, now we try to discuss in detail what is bit representation, how we are going to be calculating, how it going to be represented. So try to look out here. First, I am passing x value. Assume what is the formula? 2 to the power of x equals to y, right? Assume here I am passing x value is how much? 0. Okay, x value is how much? 0. 2 to the power of x value is how much? 0. 2 to the power of 0 means what? 1. value of y is how much? 1. Here representing only one bit, either 0 or 1. Here representing only one bit. Okay, 2 to the power of 0 means what? 1. Either one combination, either 0 or 1 combination it's going to be representing. Okay, coming to here, I'm passing x value is how much ma? 1. I'm passing x value is 1. 2 to the power of 1 means what? 2. The value of y is what? 2. I am going to be maintaining combination is what? 2 combination, 0 and 1. Okay. Here, don't confuse. Currently we are discussing about binary. Zeros and ones means binary digits, binary format. But we cannot understand binary values. I want to convert this value into what? Decimal values. Okay. I want to convert these values into what? Decimal. 0. 2 to the power of 0 means what? 1. 1 into 0? 0. The value of decimal value is what? 0. Next, 1. 1 into 2 to the power of 0 means what? 1. 1 into 1 how much? The value is what? 1. See, when we are passing x equals to 1, then 2 to the power of 1 equals to 2. We got the combination 0 and 1. I want to convert these values into what? Decimal values. The values still same 0 and 1 value only. Okay. Is it clear? Okay. Yeah. I go with the next slide. You may get much clarity. I am talking about bit representation. Observe here very carefully. Here I am passing x value is how much? 2. Okay. I am passing x value is how much? 2. 2 to the power of x. X value is how much? 2. 2 square means what? 4. The value becomes what? 4. Here 4 combination it comes. Okay. Assume 0, 0, 0, 1, 1, 0, 1, 1. Okay. Just left these values. Observe only these combinations. 0, 0, 0, 1, 1, 0, 1, 1. 4 combination it comes. Sir, why you written only 0, 0, 1, 0? Why you are not written? See, 0, 0 represents the value is what? Decimal value is what? 0. Here it is going to be calculated 2 combinations. Okay, x value is what? 2. 2 combination. One is 2 to the power of 0. Another one is called 2 to the power of 1. Here it comes 2 combination. One is called 2 to the power of 0. Another called 2 to the power of 1. For calculating this binary value into decimal value, simply we can multiply 0 into 1, 0 plus 0 into 2, 0. 0 plus 0, what is the value here? 0 plus 0. The value become what? 0 only. Okay. So I try to make clear all these things. How we are calculating? This is 0, 0 into 2 to the power of 0. How much? 1. Correct? Here 0 into 2 to the power of 1 means how much? 2. 0 into 2, 0 plus 0 into 1, 0 is equals to what is the value here? 0 is the decimal value. The next combination here 0, 1. Okay. Why I written? Because this is a 4 combination. Okay. I will tell you one shortcut also here. 0, 1 combination. Observe what is the value? Decimal value 1. How it comes? 1. This is the value is how much? 1. 1 into 2 to the power of 0 means what? 1. Here what is the value? 0. 0 into 2 to the power of 1 how much? 2. 0 into anything 0 plus 1 into 1. 1 into 1. How much value? We may get result equals to 1. The decimal value is what? 1. Similarly, the third combination is what? 1, 0. Here what is the value? 0 into 2 to the power of 0 means what? 1. 1 means what? 1 into 2 to the power of 1 means what? 2. 1 into 2, 2 plus 0 into anything 0. 1 into 2 means 2 plus 0 into anything 0. 2 plus 0. What is the result here? 2. This is the way we convert this binary into what? Decimal value. Next, 2 to the power of 0. 1 into 2 to the power of 0 is 1. Next, 1 into 2 to the power of 1 means what? 2. Add these two value. 1 into 2, 2 plus 1 into 1, 1. 2 plus 1. The result become what? 3. When you are passing x value equals to 2, then it becomes 2 square, become what? 4 combinations. Okay, see, this is the first bit 2 to the power of 0, next one 2 to the power of 1. We are converting these these binary values into what? Decimal values. So this is the combination 0 1 2 3 is the decimal values. What is the combination here? 0 0 0 1 1 0 1 1. This representation is called 2-bit representations here. Okay, sir, how to write shortcut? Very difficult to calculate. How to remember? Very easily. Always remember, for 2-bit combination, first to write 2 zeros, 2 ones. The next column you need to write 0 1 0 1. That's it. Okay, this is very easy remember. For okay, for 1 bit only 0 or 1. Okay, 0 bit 0 or 1. For 1 bit 0 1. For 2 bits 0 0 1 1 0 1 0 1. That become what? The proper table of what? Bit representation for 2 bits. Okay, I hope you understood, right? So I go with the next slide. You may get much clarity about what? Next bit representation. Say, observe. From 0 bit I am going to be teaching here. Next I go with what? 3-bit combination. Observe. Observe very carefully here. Very important. What is the value here I am passing? X value is how much ma? 3. We already passed X value 0, 1, 2. I explained. Now I am passing X value is how much? 3. 2 to the power of 3. How much? 8. 2 to the power of 3 means what? 8. 2 into 2 into 2. 2 2 is 4, 4 2 is 8. The value is 8. Here it get 8 combination. Okay, see, this is what you kept beside this one. Observe only these 3 combination. 2 to the power of 3 means how many combination? 3 combination. First is 2 to the power of 0, 2 to the power of 1, 2 to the power of 2. How to fill these values? I told you, right? Shortcut. First write 4 zeros here. Okay, because now we are moving to 3-bit combination. First to fill 4 zeros, next to fill 4 ones. Next fill 2 0, 2 ones. Okay, similarly can fill 2 0. Observe here 2 0, 2 1. Next 0 1. Next column fill with what? 0 1 0 1, like that. See, this is the shortcut. We may fill the table here, construct the table here. But if you know very well to calculation, then you may calculate it here all zeros. See, observe here all zeros, the value become what? 0, decimal value. 1 means what here? 1 into 1, the result become 1. 0 into anything here? 0. Similarly here 1 into 2, the value become 2. 0 into anything 0, 0 into anything 0. Okay, see, already I told how to calculate this table. So this is the way we constructed here. 2 to the power of 3 equals to 8, 3-bit representation. In future, we may call it is octal representation. Octal representation is going to be calculated from 0 to 7 bits. 0, 1, 2, 3, 4, 5, 6, 7. 0 to 7 numbers. Octa means 8. It is represented by what? 0 to 7. Okay. So this is about what? Binary table construction, represented by what? Zeros and ones. Okay, so this is about octal representation. So next I move to the next slide. I go with what now? The next example, try to understand. X value, I am passing X value is how much? 4. X value is how much? 4. 2 to the power of x equals to y. 2 to the power of 4 means how much? 16. 2 into 2 to the power of 4 means what? 2 into 2 into okay, 2 into 2 into 2. How much the value? 2 to 4, 4 to 8, 8 to 16. We got 16. This is called 16 combination you need to write now. Okay, how to write? How to write? Very easily. I told you, right? Next 8 bits. 8 zeros, 8 ones you need to fill. That's it. 8 zeros, 8 ones you need to fill in the first column. Say, how to construct this column, sir? Here 4 combination is there. 2 to the power of 4. It going to be started from 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3. Okay, 0 to n minus 1. 4 minus 1 means 3. 0, 1, 2, 3. Okay, the 2 to the power of 3 column you need to fill 8 zeros, 8 ones. in the 2 square means in the 2 to the power of 2, there you should fill 4 zeros. In the previous slide only in octal representation you filled, right? 4 zeros, 4 ones. Similarly 4 zeros, 4 ones you need to fill. 4 zeros, 4 ones. In the 2 to the power of 1, again you need to fill what? 2 zeros, 2 1. See how I am filling here? Very simple here. 2 to the power of 3 means what? 8. The value of 2 to the power of 3 how much? 8. I am filling here 8 zeros, 8 ones. That's it. 2 square, how much value? 4. 4 zeros I am filling, 4 ones I am filling. Next, 4 zeros, 4 1, because in binary only zeros and 1 combination only. We cannot fill other than 0 and 1. Okay. 2 to the power of 1 means what? 2. First filling 2 0, next 2 ones. Similarly 2 zeros, 2 ones. 2 zeros, 2 ones. Like that I am keep on filling. 2 to the power of 0 means what? Only 1. You need to fill only 1 bit at a time. 0, 1. Next 0, 1. 0, 1. Like that. So on. You need to fill. Then this table is called hexadecimal. In future, we may call this table construction is called hexa. Okay. Observe, sir, it is very difficult to remember. Then you can calculate it. How to all zeros combination here. 4-bit combination in between what? 4 zeros and 4 ones. First thing. Okay. In between 4 zeros, 4 ones, this is a combination. You can try out. You may get any other combination. You never. Okay. Already I filled all the combination here. If you want to try, you can try this. See, this in between 4 zeros, 4 1 combination I written here. The value, observe here, decimal value converted binary to decimal value. 1, 2, 2 plus 1, 3. This is about what? 4. Next 5. 4 plus 1, the value become 5. Next 6. 4 plus 2, 6. Next 7. 4 plus 2 plus 1, 7. 8. 2 to the power of 3 means 8. Remaining all are zeros. Next 9. 8 plus 1, 9. Next 10. 8 plus 2 represents what? 10. Next 11. 8 plus 2 plus 1, 11. Next 12. 8 plus 4, it become what? 12. Next 8 plus 4 plus 1, 13. Next 8 plus 4, 12 plus 2, 14. 8 plus 4, 12 plus 2, 6. 8 plus 4, 12 plus 4, 14 plus 1, 15. So this is the construction of what? Hexadecimal. Okay. Hexa is going to be calculated from 0 to 15. But generally, the decimal numbers are represented in mathematics 0 to 9 only. So if you are all mathematical students, you are familiar about number system. In number system, decimal values are categorized by what? 0 to 9. Base 10 represented by what? 0 to 9 numbers. Okay. From 10 onwards, they are going to be categorized by what? A, B, C, D, E, F. For your understandably, I written here 10, 10, 11, 12, 13, 14, 15. But generally in hexadecimal system, they won't represent 10, 11, 12, 13, 14, 15. They will represent it either capital A or small a, capital B or small b, capital C or small c, capital D or small d, capital E or small e, capital F or small f. See, this is the representation of what? Hexadecimal hexa number system. For binary to what? Hexa value. See, I hope everyone is clear about what bit representation. I started with what? 0 bit, 1 bit, 0 bit, 1 bit, 2 bits, 3 bit combination, 4 bit combination, so on, so on. 8 bits represented by what? 1 byte of memory. See, similarly you can construct like 5 bit, 6 bit, 7 bit, so on. 8 bits combination represents what? 1 byte of memory in computer. I want to store 1 character. Okay, in computer, just a moment. Yes, I want to store 1 character like A. I want to store 1 character A. I required how much byte? 1 byte of memory. 1 byte of memory. Okay, this 1 byte represents what? 8 bits of memory, 8 bits of combinations, that is in between 8 zeros and 8 ones. Okay, I don't want to get much confused, that's what simply written here. Similarly, up to 4 bit I explained, right? Similarly, go with what? 8 bit combination. It is represented by what? 8 zeros and 8 ones combination represents what? 1 byte of memory. In computer programming, I want to store any one character into the memory. Then we require how many bits ma? 8 bits is required. That represents what? 1 byte of memory. See, here in between I represented here all 1 values. Observe here. 2 to the power of 0 means what? 1 here, decimal value. 2 to the power of 1 means 2, decimal value 4. 8, 2 cube means what? 8. 2 to the power of 4, 16. 2 to the power of 5, 32 bits. 2 to the power of 6, 64 bits. 64 value here, sorry, bits. 2 to the power of 6, 64. 2 to the power of 7 means what? 128. 2 to the power of 8 means 256. Here 8 bits combination. 2 to the power of 8 means what? 256. Okay, in C language these 256 characters are represented. 0 to 255 unsigned characters are represented. Okay, don't worry sir, what is the signed and unsigned characters, we'll discuss in the coming sessions, but you need to remember 8 bits value is how much? 256. In future, in data types of C programming language, there will discuss 256 is going to be represented 0 to 255 characters. Okay, that is called unsigned characters representation in C language. Similarly, 2 to the power of 9 means 512. 2 to the power of 10 means what? 1024. In future, this 1024 is going to be represented 1 kilobyte. 1024 bytes represents what? 1 kilobyte. Okay, yes, time is running up. I try to stop the session up to here. In the next session we try to discuss in detail about measured units of data, like what is 1024 bytes represents 1 kilobyte. I given clarity here. 8 bits represents 1 byte. I given clarity here. In the next session we try to discuss in detail how it going to be measured the units of data. 1024 bytes represents 1 kilobyte. 1024 kilobytes represents 1 megabyte. Like we try to discuss in detail in the next session. Okay, yes students, see I given much clarity over here about data. Okay, about data hierarchies. Okay, and what is bit, byte, field, okay, records, files and database. And also I discussed in detail about what is bit. It is represented by 0 or 1 combination, and also explained clearly about 0 bit representation, 1 bit representation, 2 bit representation, 3 bit representation, okay, 4 bit representation, so on. Lastly, I explained about 8 bit representation with relevant values. Okay, yes, if you really like these videos, make it like, subscribe, you may get more updates regarding this programming in C language. Thank you so much.